Hi guys, today we do lesson 2.4 for calculus. Now this lesson is all about a specific application for derivatives. This is a very big application. You can pretty much guarantee you're going to see it on the AP test, and if you're taking physics right now, it'll probably help you a little bit. So this application is talking about position, velocity, and acceleration. Here's the gist of what we're talking about today. If you have a position function, if you differentiate or take the derivative, same thing, you end up with the velocity equation. If you differentiate again, so take the second derivative, you end up with the acceleration equation. So velocity, or your speed, or is a slope or a derivative of your position. So here's a couple important terms. We kind of just talked about position, velocity, and acceleration. Your initial position is your starting position. So basically S of 0. By the way, here are all these different terms for position. You could use S of t, X of t, or Y of t. We usually use S of t, that's the one I'll use a lot. Velocity is always written as V of t, and acceleration is always written as A of t. Okay, then we have initial velocity, that would be V of 0, so plug 0 into your velocity equation. You have speed, which is the absolute value of velocity. You have displacement, which is the final position minus the original position. And then we have distance, which is the total distance traveled, and here's the key, all direction changes must be accounted for. So there's our vocabulary for today. Let's start to practice a little bit. So I have this equation. Because it's S of t, I can assume this is a position equation. It says find V of t and A of t. So V of t is going to be S prime of t, so I need to take the derivative of my position. So I look t cubed. I have a rule for that. I have a shortcut. The exponent goes in front, and then I minus 1 plus secret 1, so the exponent goes in front, and then I minus 1. So if I simplify that, our velocity equation is going to be 3t squared plus 1, because this will be t to the 0, which is just 1. Now I want to find A of t, which is going to be V prime of t or S double prime of t. So I'm going to take the derivative again, so the 3 stays out in front, and then I do my rule on t squared, so the 2 goes in front, and then I minus 1. And derivative of a constant is 0. So if I simplify that, I should get 6t. So that is our velocity and acceleration equations from the position equation. Now let's start to apply this a little bit. So use this position function to answer these 2 through 11. Now here's an important distance. Units are measured in feet. Time is measured in seconds. So that should tell you really quickly, any S of t answers will be in feet because S of t is position. Any velocity answers will be in feet per second. You can kind of think of velocity like speed, so feet per second. And any acceleration answers will be in feet per second. So those are your units for any answers that we have down here. So first off, what is the initial position of the object? So initial position, if you look up here, that is S of 0. So S of 0, that's going to be 16 times 0 cubed minus 36 times 0 squared plus 24, which if I simplify is 24. This is a position question, so my unit is going to be feet. Okay, now I have the velocity of the object at t equals 1. So first I need a velocity equation. So I need to find s prime of t. So the 16 stays out in front, and then I do my rule on t cubed. 3 goes in front, and then I minus 1. Minus 36 goes in front, do my rule on t squared. 2 in front, minus 1. And then derivative of a constant is just 0. So v of t is going to be 16 times 3, which should be 48 t squared. 36 times 2 minus 72 t. And I want to know what is the velocity at t equals 1. So that's essentially asking what is v of 1. So then I have 48 times 1 squared minus 72 times 1, which is going to be negative 24. And this is a velocity, so my units are going to be feet per second. Next, what is the speed of the object at t equals 1? So reference up here, speed is the absolute value of velocity. So all I need to do is take my velocity at t equals 1, which we already calculated in number 3, and take the absolute value of it. And that's going to be my speed. Okay, next, what is the acceleration at t equals 1? So now I need to find my acceleration equation. So I'm going to take the derivative of velocity. So 48 stays in front, and then I have to do my rule on t squared. So the 2 goes in front, and then I minus 1. And then 72 goes in front. I have a secret 1 on that t. So the 1 goes in front, and then I minus 1. So my acceleration equation should be 96t minus 72. And this is saying what is the acceleration at t equals 1. So that's basically a of 1. So 96 times 1 minus 72 is going to give you 24. And this is acceleration. So my units for acceleration will be feet per second. Okay, number 6. When is the object at rest? If it's asking for an object at rest, that is saying when velocity equals 0. So we're going to take our v of t equation, 48t squared minus 72t, and set it equal to 0, and now we need to solve. So I look at this, I have a greatest common factor that I can take out, 48t, which is going to leave me with a t minus, oops, that's not my greatest common factor, is it? I think it's 24 actually. Let's try that again. 24t, so we get 2t, yep, there we go, minus 3. Now, if you remember back from Secondary Math 2, we're going to take each of those, set them equal to 0, and solve. So I have t equals 0, and divide by 2, t equals 3 halves. Now, these answers are time. We solved for t. So that means these answers will be in seconds. Okay, this is already a long video, so I'm going to stop this one. In the next video, we'll continue talking about these same problems in a couple different applications.